one of the reasons why we're a part of this lovely event is because, as was mentioned, we're participating in this incredible exhibition at the State Studio right now called Near Futures and Quasi-Worlds. And we're showing an artwork called Hilbert Hotel. And the point of departure is a paradox of early 20th century mathematician David Hilbert as to how a hotel of infinite scale could accommodate an infinite influx of continuously arriving guests.
And though mathematically this is possible, so you can operate with infinity sets, and you can never say that one infinity set could be bigger than the other infinity set. They're all infinite. However, in practice, you would need to move every guest every night to a new room, and it's quite an impractical solution. So can infinity exist in the real world? And since we are asked to share our methods, maybe you can share our presentation. So we prepared some slides for today, and we'll share them with you. So we will start with the constraints. So unlike many artists, we work in a very systematic manner because we follow some very strict constraints, and they're as follows. You can read them on the screen. So we do not use any solid media. We do not use any recording playback media. So we can't use photography, video, film, sculpture. We do not use any representation or simulation of reality. So for example, we don't represent particles by drawing them as little balls, or trees by making photographs or pictures of trees. And we also try to concentrate as much as possible and to present as much as possible world as a
fluid.
Yes, as waves, as fields. And that is why some of the media we work with are liquids, gases, sound fields, electric fields, as in the case of Hilbert Hotel that is now on view at the State Studio. So now that you see the constraints and you're familiar with our method, you can create an artwork just as we make them. It is not easy to follow these constraints, and in the very first artwork we didn't manage to do so. But starting from the second one, yes, it is quite plausible. Maybe we should make a full screen.
Yes.
So, and we also would like to share some of our inspirations. So we will share the books that we are reading at the moment. This is a book by Max Tegmark. He is a cosmologist, a physicist working at MIT. We had no idea about his work until in March, one of our students at the Frenois, an art student, she asked our opinion about a very scientific artwork of Max, article of Max Tegmark called Consciousness as a State of Matter, which is quite shocking because usually physicists will not try to give you a description of consciousness deriving from mathematical formalisms and principles of quantum physics or something like that. So we were immediately very intrigued by this article. We've been reading it for a few months and discussing. You can find this article at Archive newspaper website. So, and after we discussed the article, we moved to his books. So this is his book, Our Mathematical Universe, that is written for general public. So you don't need to be a scientist to read it. And it covers, the reason we liked Max's approach is because he offers this very comprehensive view to reality. He is cosmologist, but he goes into problems of consciousness, quantum physics, and cybernetics. And he even studied...
And foundations of mathematics.
And foundations of mathematics, yes. So it is, I don't agree on everything with Max, but it's amazing to travel the labyrinths of his mind.
The second book might be far more familiar to many of you.
Yes, and this is a classics. This is a book by John Bell, a scientist who was working at CERN in the 60s, and in his spare time he was writing some articles. And in this volume, in this book, are collected his articles, his short articles, especially on foundations of physics and philosophical problems of quantum mechanics.
Yeah, something that Bell called quantum philosophy, which actually, after his efforts, were actually materialized into experiments.
And we've read these books, we've read this book before, but we have revisited it again in the beginning of July for our conversation with Tomasa Kalarko that we did at the opening for the exhibition that is now at the State Studio. And the interesting thing about this whole debate about the interpretation of quantum mechanics and how can we understand the mathematics of
non-locality,
and just to make a general meaning of this very strange, weird wave-like behavior. So basically, quantum mechanics is a wave function that lives in Hilbert space. So it's mathematical space where a mathematical wave dynamics, the best way, the most precise way to describe our reality, but for our senses that doesn't make any sense. And there are many interpretations of quantum mechanics, from Copenhagen interpretation to Bohm's interpretation to many world interpretation. They all use the same mathematics. The mathematics is the same, but the words we add to it are all very, very different.
Now, here's another article that we have been recently pondering, and which also has to do with our various art endeavors involving ion traps. Here we have several proposals of creating an analog of a black hole pair united by a wormhole, and this is all done by means of a highly entangled chain of ions. So we can imagine that in the chain of ions that you see at the bottom of the screen here, that the left side and the right side are two very tiny black holes, and in the middle is a wormhole that is traversable, that allows for qubits, quantum bits of information that are encoded on the left side to mysteriously be focused on the right side. And in fact, one of the only ways to interpret what is actually happening in this ion trap is that there is some sort of wormhole forming in between.
Dmitry and Evelina, I think there is indeed a problem with your slides because we're still stuck at Max Tegmark slides. So
no. Okay.
I have it as a backup, and I will share it, right?
Yes,
well, no. But let's try to let's see if it returns. Let's see if we can.
No, but maybe Lisa, you can share our presentation. So yeah. we have to stop sharing our screen.
Okay.
I think the reason is because sometimes you choose just to show like a certain picture, or you have to choose that you show your entire slides and so on. So now you can choose again, and then it should work.
Well, let's try it again, and then we'll see.
But where do you choose this one picture, or?
Let's see what happens here. All right. Have we arrived at?
Perfect.
Okay, good. Great.
So let's okay. So let's move to the previous slide. No,
Oops.
previous.
How about
Okay.
that? Is that working? Is the switching of the slides working?
Yes, it works great.
Okay, so now this is the book of John Bell, Speakable and Unspeakable in Quantum Mechanics. So do you see the slides?
Yes?
Yes,
Yes.
Okay, great. And this is the next article we were discussing, the quantum gravity in the lab, teleportation by size and traversable wormholes. So these are the kind, it's a very fresh article. So these are the kinds of problems are tackled with help of ion traps. And again, we remind that Hilbert Hotel that is now on view is a kind of very crude model of an ion trap, very large scale macroscopic ion trap.
And so we move into Hilbert Hotel, where you're actually observing hollow glass microspheres that are levitating in alternating electric fields. And perhaps one of the most curious aspects of what you can perceive is that these microspheres are moving along square-shaped orbits. And this is due to the fact that they are tracing the quadrupolar electric field that is keeping them airborne. And we're going to move into another artwork which has much to do also with the article that we're currently reading. This here, in fact, was presented in Berlin in 2017, premiered there. ER equals EPR.
And this is, so that's our 10 minutes. This is, here you can see an installation view, and here we present a fluid dynamic analog of a black hole, which is a vortex, and here it's a pair of vortices, so they are connected by this string, this vortex string, and if you cut the string, they immediately disintegrate, they dissipate. However, if the string connecting them is not cut or keeps existing, they will float for quite a long time. We do it here in a 2-meter aquarium, 2-meter long aquarium, and you can see a laser projection that shines through the vortices, and you can see it greatly magnified on the ceiling. So it's a kind of it's an fluid dynamics analog of this proposition from string theory, ER equals EPR, that equates entanglement on the quantum level with wormholes on the level of cosmology.
And this is yet another one of the artworks which we developed during a residency with LIGO. That was the group, the Laser Interferometer Gravitational Wave Observatory that were responsible for this extraordinary apparatus that for the very first time was able to register the gravitational waves emitted by the collision of black holes.
So since we already over time, I think we'll finish here. Thank you very much.